These are the solutions to the questions at the end of lesson 9.2. Now, number 1, we know that intensity is proportional to E0 squared, so that is B. Number 2, now to calculate the phase difference, we need the path length difference, so that is B. Number 3, looking for the statement that is false. Now, A is true, but B is false because the wavelength in a refractive index n is actually going to be the vacuum wavelength divided by n. And C, D, and E are all true. So B is the one that is false. Now, number 4, we have a thickness of material. Now, refractive index is 1.4 and it is 75 microns in thickness. Now, we're looking at light travelling through there relative to light just travelling through free space. So for light just travelling through the vacuum or the air, then the path length is simply L, which is 75 microns. But this beam that went through the refractive index that was higher will have a path length through that section is N times L, which is 1.4 times 75, and that is 105 microns. So that means the path length difference, delta L, is 105 minus 75, which is 30 microns. And now comparing it to lambda, so delta L over lambda is 30 microns over 600 nanometers, which is 30 by 10 to the minus 6 over 600 by 10 to the minus 9, and that turns out to be 50. So the path length difference is 50 wavelengths. Now, number 5, we are looking for constructive interference in this film. So we have the first ray bouncing off the front face, the second off the back face. For constructive interference, remembering that we've got air, film, and air, our condition is that 2nt should equal m plus a half times lambda. Now, the least thickness where this will be true is the m equals 0. So we have 2nt equals a half lambda. We want to find what thickness that is. So we get t on its own, we divide both sides by 2n to get lambda over 4n, which is 624 by 10 to the minus 9 over 4 by 1.33, which is 1.17 by 10 to the minus 7 meters, or 117 nanometers. Now, number 6, we have an AR coating, and to be anti-reflective, we want destructive interference for the reflected rays. And the condition for that is 2nt equals m plus a half lambda. Same equation as above, but here we're going from air to coating to glass. So we have no phase shift, and that's why it turns out to be the same equation. So we have 2nt equals m plus a half lambda. That means 2 times 1.5 times t equals a half lambda to have the narrowest coating. So that means t is lambda over 2 from this half and another 2, which is 4, times 1.5, which is 3 centimetres divided by 4 times 1.5, which is 6, and that is 0.5 centimetres. Now number 7, we've got our film, we've got air, soap, air, refractive index is 1, n 1, and we know that n equals 1.33. Now we're looking for destructive interference because they say dark fringes. And we know that the thickness is 296 nanometers. Now the equation for destructive interference is that 2nl equals m lambda. And we're looking for the second fringe. That means m equals 2. So we have 2 and L equals 2 lambda. These cross out. Lambda is NL, which is 1.33 times 296 nanometers, which is 394 nanometers.